All right, we're going to go ahead and get started. And today, Max and I will be talking about our foray into some entry-level game hacking with the title here, Don't Play Fair, Game Hacking for Security Professionals. Uh-oh, I don't think this is working.
Try it.
There we go. Okay, so quick introduction, a little bit about me. My name's Nick Powers. I'm currently a service architect at SpecterOps. I've spent most of my career in like pen testing and red teaming. And my handle on Twitter, GitHub, everything else is @Zenergy.
Hey, my name is Max. I'm a Clemson graduate. I now work at software engineer at Prelude. I used to work with Nick at SpecterOps. And my Twitter handle's up here, 0xDabo. So.
Awesome. Let me stand a little closer over here so I can see the slides. Oh, yeah. Okay, so just to give a quick intro about what we'll be covering over the next 25 or 30 minutes is first we'll cover why we think this is relevant to offensive securities in general, how it kind of had some overlap with our day-to-day in the industry. We'll give an overview of the game that we're going to be focusing on, a little bit about how the game works, like its functionality, as well as kind of like the intro into some of the like suspicious behavior we saw that we thought might be exploitable. Max will dig into actually weaponizing this client-side abuse and making it practical to abuse during like the multiplayer gameplay. Then we'll go over a demo, kind of tying all of the abuse together, and we'll wrap up with some real-world application of like how some of these techniques bleed over into our everyday work. So also, still kind of like introducing this topic, we are not game hackers. That will probably become apparent. This isn't like a huge game that we're digging into hacking. So we're basically just cosplaying game hackers at this point. But we do play video games, and we do think that what we kind of learned along the way here has a lot of overlap with offensive security. So anybody that's familiar with the industry or things associated with the offensive security industry might be familiar with topics like process injection, Windows internals, reverse engineering, whether that's static or dynamic reverse engineering. Definitely a lot of overlap in that regard. And lastly, like I mentioned at the end of the presentation, we'll kind of tie some of these techniques together to at least one or a couple real world scenarios that we've seen in like assessment scenarios or even in other corporate networks that we've been exposed to. So why did we do this? Well, I mentioned before we play video games. We enjoy playing video games. And while we were playing some of these the game that we'll be focusing on in this presentation, a friend of ours was like, we were in the middle of a game and he focused the window, like he just held the window so it kind of like froze the game up. And the rest of us noticed certain like values in the games or game or functionality in the game started to work a little differently. So that was like our first kind of exposure to like some of these values might be controlled on the client side of the game versus like validated on the server side of the game. So we thought that might be interesting to focus on, potentially exploitable. And again, like I mentioned before, this was kind of our like foray into like entry-level game hacking, like our baby's first cheat, but it made it a little bit more interesting in my opinion because this is a multiplayer game, so the effects kind of, you know, the friends that we were playing with got to see like what was happening as well. So how does the target game work that we're talking about? It's a very simple game. You start off either as a hunter, so this is the view for being a hunter, or you start off as a deer. There's one hunter, the rest of the players are going to be a deer. The goal is to find the other players that are deer that kind of blend in amongst all the like NPC deer. But to give a little bit more specifics of like how each role works, if you start off as a hunter, you see here the hunter has a certain amount of arrows in the bottom left. Hunter also has a sanity bar you can see at the top, so there's only like a limited amount of time to like find the other player deer versus the NPC during the game. And you'll also see in the bottom right there's some trail cams that helps the hunter like find some of the other player deer blending in amongst the NPCs as you're playing. And then if you're a deer, the game developer decided to implement this feature that's like a sprinting feature, but you can see to help you get away from the hunter, there's this very helpful farting feature that kind of shoots you across the map. So there's a pro and a con here. The pro is obviously you get away from the hunter, but the con is it makes it obvious where like you're not an NPC, you're one of the players that you're trying to, you're avoiding the hunter. So if the hunter sanity runs out like towards the end of the game, all the deer turn into these like monster Wendigo creatures, and then it kind of reverses the role. You get to hunt the hunter, and that's how the game ends if the hunter doesn't find the deer. So that's a quick overview of kind of like how the game works. But as we were digging into what might be abusable here, we mentioned the whole like holding the window, some values might be controlled on the client side. The first thing I already mentioned, this is a multiplayer game, so values being controlled on the client side is not a good thing if they're not being validated on the server. So we need to determine which one of those values are controlled on the client side. And the first thing that came to mind for us was I mentioned the trail cam feature. You can see in the bottom right of the next slide that I'll go to here in a second. The hunter can put down a few trail cams that lets you, like, if a deer runs by it, you'll see where they are kind of roughly on the map. And you start with 6 that you can lay down. So that's like a finite number. We can look for that number potentially in memory using a tool like Cheat Engine. And giving a quick overview of what Cheat Engine is, it allows you to do things like scan memory for particular values, like an integer of, let's say, like 6, like the hunter starts off with 6 trail cams. And we can filter that for that value as the value changes. So we have 6 trail cams, we set down a trail cam, now we have 5, and we can continue to filter down those potential values in memory until we find the one that's like, this is definitely representative of the amount of trail cams we have in the game. So this is what it would look like. You start off the game, you're a hunter. You can see in the bottom here, we have 6 trail cams left. We're about to sit one down. So then in Cheat Engine, we attach to the game process, and then we can scan the process memory for this value that we're interested in. So here we just look for 6, but the problem is you can see in the top left here, roughly, that we have over 100,000 values that equal the number that we're looking for. So not going to be helpful at first, but like I mentioned, we can just keep setting down trail cams. We set one down, now we have 5. We filter, we continue doing that basically until we find the value that we're interested in the target game process memory. And then we can arbitrarily modify that value. And we'll see here, if that value is not validated on the server side, which is kind of like what we're getting to here, not only on the client side, but for all the other players in the game, we'll have an arbitrary number of trail cams, and that can lead to chaos in a lot of scenarios. So we can just control potentially any of these values.
So, let me get this camera.
Yeah, here, I'll switch with you.
You have to like put your hand up. It got me. It's got me. So while that's really cool, that doesn't really work in a real game. You know, that might take that might be a 3-minute process to find a value, modify the game, search for the value again, modify the game until we find the right value. That won't work. The round will already be over, and you just don't have enough time for it. So is there a better way to do this? Yes. Cheat Engine has great support for scripting, so we could have scripted this out in Cheat Engine, but we decided not to do that. We decided to develop this cheat outside of Cheat Engine because it allows more flexibility. So we did some researching. We're extremely lazy security researchers, so we looked on the internet, how do most cheats work? Well, it's actually a pretty simple process. You inject code into the game process so that you have code running as the game, and then you can modify whatever values in memory you want as the game. So we decided to use a DLL, really nice little feature, package up some code for us. We can inject this DLL into the target process and start modifying values we want. So how does this work? It's a pretty well-known technique called cross-process DLL injection, or just cross-process process injection. Uses a number of internal Windows API functions. So we can see we have a loader script on the left-hand side and the game client on the right-hand side. In order to perform process injection and load a DLL, we first call open process to get a process handle. Then we use virtual alloc EX and write process memory to write the DLL path into memory in that remote process. And then we call create remote thread, calling load library A. What that's going to do is find that DLL path in memory that we set, load the library that we've designated, which is our malicious code, and boom, we have code execution in the target process. So if you've ever done C2 internals, looked at how Cobalt Strike works, this is exactly what Cobalt Strike does for most of its post-ex capability. So if you do PowerShell, PowerPick, execute assembly, any of these, they're all implemented the same exact way. Instead of loading a library, it may run PowerShell or unmanaged PowerShell or load a .NET assembly. But this is, we're using things that we do in our everyday job to hack games. So it's kind of this fun fun similarity there. So we're now able to execute code in a target game. What are we going to do? We want to modify values. How do we modify values? Instead of searching for them every time, how do we find them every time we start up our cheat? How do we load and find these values that we need to modify? Well, there are these things called offsets. So offset is just the distance from the beginning of an object in memory to a property we're interested in. Why do we need these offsets? Well, memory addresses change. You have a base address that will be randomized every single time. If you find where the trail cam number is, close the process, open it back up, the place in memory that trail cam value is going to be different every time. So we need these offsets because they will stay the same every time, because that object is packed in a specific format, whatever the struct that we're using is. It's going to be the same every time. So if we can use offsets, we can always find the value we want to change. So cheat engine is good. Doing this is like find by value. We're finding an address by value. We can also use find by address or find by offset, which is a much better way to run cheats, where you can do it quickly in an automated fashion. Cheat engine does have scripting support for this scenario exactly that we're about to perform. But again, we chose a DLL. It's more fun to implement from scratch. So what are offsets? Let's take this little toy example of a game. We have a world object. We have a player object. So we have this world object. When we execute this in memory, the structure will be pushed onto the stack. The beginning of that structure is the world. And the offset that we're interested in is hex 24 bytes away. That's where this player object, this player pointer, is located. Then we have the player object, and we have a health, which is hex C bytes away from the beginning of the player object. So if we know where the world object is in memory, if we can discover that, we can always find where health is by going to the beginning of the world object, going hex 24 bytes forward, evaluating where that pointer is, going to the pointer, and then going hex C bytes from the beginning of the player object to that health place, that health integer. This is how it would look like in memory. So we have this world object. In memory, let's say that the world object is static, so we can find it every single time. We have this world object. It hex 24 bytes later, we have a pointer to the player object. Hex C bytes away from the beginning of the player object is the health address. So what's really nice, in most video game platforms, for whatever reason, a game developer is going to need to talk to me about this, but world objects are typically static. So the nice thing about static variables is you know where they are every single time. They have the same offset every single time because they live in a different part of executable space. So let's find these offsets. We could do a lot of reverse engineering, but neither of us do a lot of reverse engineering, like low level, I'm not the best at Ghidra. But we have this thing called Unreal Engine. So Unreal Engine is the game platform that the game that we've compromised or written hacks for is built on. So let's do some enumeration. Let's see, has anyone written tools for finding offsets in Unreal Engine? And the answer is yes. There's this tool called Dumper7, which works up to Unreal Engine 5, has support for pretty much any Unreal game. Super easy to use. You build a DLL, use like Process Hacker or System Informer to load that DLL into the target game, and it dumps a C++ SDK that has all of the offsets predefined in like C++ classes. So this is super useful for us. We automatically build a C++ SDK. All of our offsets are defined. We can just write C++ as if we were the game, and we have code execution, malicious code where we can start referencing values in memory. So how does Dumper7 work? So like I said, getWorld is typically a static object for most video game platforms. So we can find the world object by getting the image base. We'll see how image base works in a second, and then adding that offsets : gworld in the offsets namespace, that gworld static offset. Get image base just gets module handle 0. So this is, we get module handle 0 will get us the beginning of the game. So we've injected this DLL into this game memory. Get module handle 0 will get us to the beginning of this game. And then you can see offsets is just a static, that's a integer offset value that we add to that image base, and we get where gworld is every single time. The other important thing here is gobjects. So every object in Unreal is in a packed as a list at the beginning of this G offset value. So any objects, you can reference it by G objects and then perform your enumeration from there. So offsets, very easy to get if you're looking at Unreal. So let's dig into the code a bit. Let's look at this SDK that was dumped. We see this hunter character class, this A hunter BPC. This is the hunter character class. We can see some pretty interesting objects or properties here. We have current arrows, player name, max arrows. Like this is kind of indicative to us that this is the class for the hunter object. So if we want to modify anything, it's all right here. So let's see if these offsets are correct. Well, we're going to use this SDK. This is a for loop that just enumerates through all of the G objects in the game. We attempt to see whether that object is a hunter class or not. So we just use this isa function that comes in dumper7. We check to see if the object that we're enumerating is a hunter, and then print out the name, print out the player name, and we'll see if this works, or does it crash? The answer is it works totally fine. We print out the object, and then we print out the player name. We can see the offsets that dumper7 gave us are entirely valid. So this is going to make hacking this game so much easier. So let's see if we can modify arrows. So we've injected this DLL, and we filter for, is the name my Steam username, and then set the current arrows to 1,000. And we can see this works really well. It modifies the number of arrows I have to 1,000, and then I shoot one off 999. And it's able to find my player object in memory. So this is the basis of all the rest of the cheats we're going to perform. We load a DLL using process injection. We have all of these offsets defined with this SDK that dumper7 provided us. So let's try another cheat. Well, we wrote this helper function called find actors, which just performs that isa function on every object in the game and returns us all actors of this A deer BPC. We did some enumeration. Again, we're lazy security researchers. There's a whole documentation page of Unreal, how Unreal works. In Unreal, there's this object called a mesh that every character object has. We can enumerate the mesh, and there's two functions, set render custom depth and set custom depth stencil value. If we do that, we can highlight all the deer, all the non-NPC deer. So we've won this game. We know where every player is in the game. We can just walk up to them, they're highlighted, and shoot them. So we can see there's deer here that are not outlined. We find this deer and 360 no scope them. And that's a player. This was just a public lobby. So that's where the rest of our game, that's kind of the basis of all of our hacks.
Cool. So yeah, Max gave a couple demos of drawing kind of stenciled outlines around, helping us distinguish the NPC deer from the actual players. We showed removing cooldowns from certain game functionality, but we wanted to kind of tie this together and what the gameplay looks like from our perspective after we combined everything that we found. So we play video games every Monday night with a group of friends. We didn't tell them that we had done this. We'd been playing this game for a little bit, and we just recorded their reaction with a few seconds of gameplay. So if the
audio works.
Yeah, we'll see if the audio works. But before I play the first clip, if you remember, before I handed it over to Max, I showed the incredibly crucial feature of the game where the deer can fart away from the hunter. And that was one of the removing a cooldown from that feature was something we were very interested in targeting in this game. So that's kind of where we start in this demo. So hopefully the audio works here.
Am I? Oh.
So we're obviously starting as the deer, drawing him over to us.
What? All right. Eating, bro.
What is that guy doing?
That guy going sicko mode.
So our friend stepped up to the challenge of
I'm gonna get it if it's the last thing I do.
Good value. Oh way. He's legendary.
This is so sick.
Oh, he did it! He did it!
Oh my god. Anyways, I'm going mode.
We had to bleep a lot out there.
So I did also, like, that was from the deer perspective. I wanted to show what it looks like actually on our screen. So like Max mentioned, we wrote the loader, like the executable that injects the DLL. Just a very like simple screen here, like one for deer hacks, two for hunter hacks, some other features we were testing there at the end. So we start the game. It's as easy as pressing 2. It does a lot of what Max talked about, but kind of in an automated fashion. And we can see it outlines. We have basically machine gun arrows here. And we can kind of skip to some of the gameplay of what it looks like to be the hunter in this game with our friends.
Am I?
Oh.
Oh, that's skip back.
Am I?
Oh.
Am I? Am I?
Oh.
I don't know.
Am I? Am I?
Can we switch out of speaker mode maybe? That's not a huge deal either way.
Yeah.
Oh.
All right. Well, we're supposed to be able to skip this, but we can do it up here.
Oh yeah, that's a good idea.
Where was it?
Like 75% of the way through, a little past that. Yeah, that looks good.
Look at that.
There it is. Okay.
Yeah.
Yeah, so this is actually starting a game we were playing with them from the hunter perspective. So you can see outlines are there. We're kind of going around the map, unwitting to them. Poor guy here, hiding behind the rock, not anymore. And yeah, there's no way to get around that, really. Although our friend here makes a valiant effort, but.
And at this point, everyone in Discord is like freaking out, so they know what's up.
Yeah, the jig is up here. There's no.
But
no,
he tries.
Yeah,
he tries.
He tries to get
He's
around.
Trying to
he
juke
makes a good
us.
effort.
Still no. It's a good effort.
Okay, so hacking the game was a lot.
You need to raise your hand.
Oh, yeah. There we go.
There
Okay.
we go.
Nope, it's still on you.
Okay. It likes me. Oh,
I'll just stand there.
yeah. Stand next to you.
Cool. So hacking the game was a lot of fun, but we did want to tie this back together with like how this relates to our everyday job in offensive security. So like I mentioned in the beginning, there are several real world applications of these techniques, in my opinion, and a couple that we actually leverage during like assessments in some of the networks that we see. So the core of this is that the same logic, or finding these client-side control values, applies in a lot of scenarios, particularly in offensive security. When a value is completely controlled by the client and not validated in any way by the server, there's a lot of room for abuse there. So again, what we're looking for is making sure that we want to make sure that the server of whatever client application is validating the integrity of these values. When that's not happening, we can do things like the practical application we have here is abusing posture checks of devices connecting to like VPN. That would usually happen during like the SSO or single sign-on process, making sure a device is in a certain state, like enforcing disk encryption, making sure AV is installed, simple checks like that. But again, if the integrity of those values are not validated on the server side, if it's a simple like, yes, no, is this enforced, is this not enforced, and that's sent up to the server and not validated, there's room for abuse there. So where the game hacking, it was a simple, like the server's not checking if we have only 3 arrows, now we have 1,000. In this use case, it's if the server of a posture check, when you're connecting to a VPN, doesn't actually do anything to validate, is disk encryption enforced, is certain security products installed, then there's room for abuse. So in this case, we didn't want to like target the particular software here, but because they're not really doing anything wrong in this case, it's just this is how a lot of posture checking works. There just needs to be some integrity on the server side. In this case, the check you can see that's failing right here is BitLocker disk encryption. So The problem here is that it's just a true false. Like, is it enforced? Is it not enforced? That's sent to the server. You can see when we try to log into the single sign-on, just like Microsoft authentication here, we get an error because BitLocker encryption is not enforced. So just like Max told us, just like we stepped through with the offsets, finding the right functions or properties in memory, we do the same thing here. We inject into the remote process, find the right base address, find the target function using the offsets, and then we inject the right bytes to just kind of overwrite that function, say always return true instead of actually check it. Once that's done, we just try to log in again because the integrity of that value is not checked on the server side. We're allowed to actually authenticate. So to kind of wrap this up, we wanted to make reference to, first I'll reiterate, again, we're not like professional game hackers. We have a lot of respect for the community that does this like regularly and very well. We also wanted to give a shout out to the author of the Dumper 7 tool that we leveraged for this, as well as a YouTube channel of a guy that both of us watched a little bit to kind of get more familiar with these topics. And lastly, just the guided hacking forum in general provided a lot of like advice along the way as we were learning this. So anything else?
I think we're good.
Cool. Well, that's it. Thanks, everyone.
Thank you.